Hey, what's up, you guys? Here we go. Lesson 2 here. We're solving quadratics by factoring. If you remember lesson 1, we were solving by graphing. Now we're doing factoring, which I think you'll actually like a whole lot better. And I just want to remind you before we get started here that when we say solving quadratics, that means we are finding the numbers that make our quadratic equation 0. So we're trying to find the zeros. So we're going to focus on this orange equation on the left-hand side. So we're trying to find two numbers, maybe one, that make this whole equation turn to 0. All right? So as I look at this, I say, hey, you know what? What they're doing is they're taking x plus 2 and they're multiplying it by x minus 3. So we could just make one side 0. That would actually make the whole thing multiply equal 0. So let's just look at this piece here. What could we plug in for x that would make just this parentheses equal 0? Well, this is x plus 2, right? So what if we plugged in negative 2 for x? All right, well, then it would be negative 2 plus 2. And then we'd also have to plug in negative 2 here, right? So we do negative 2 plus, or minus 3, excuse me. And here, in this first one, we'd get negative 2 plus 2 is 0. Boom, that's what we wanted. Because now, it doesn't even matter what this is. It's negative 5. Doesn't matter, though, because 0 times negative 5 is just 0. And we have effectively made our equation here equal to 0, which is what we want, right? So that means one of our answers here is negative 2. That's one of our answers for this first one. Now, we could also say, hey, let's just make this side 0. What can we plug in for x over here to just make this parentheses here 0? What minus 3 equals 0? And doing a little quick mental math, if we just plugged in a positive 3 here, I think 3 minus 3 is 0, right? So we'd be plugging in 3 to both of these, and we don't really, that's not a negative, we don't really care what we get over here on the left-hand side, because what we care about is that, hey, this is 0, and 0 times anything, whatever we get here, which is 5, 0 times 5 is just 0. So our other 0 is 3. So our zeros are negative 2 and positive 3. You guys, if I were to graph this thing, and you don't have to now, because we have this shortcut, if I were to graph this thing, we know, without even having done any of the axis of symmetry and vertex stuff, we know that at negative 2 there would be a 0, and at positive 3 there would be a 0. And this graph would look something like that. Cool? So that's the first example. If you have an equation that looks like this, you can say, hey, let's make this parentheses 0 or this parentheses 0, and that will give us our zeros and our answers. All right, if we take a look here at the graph on the left-hand side now, obviously it looks a little tiny bit different, but we have an x by itself here, and we have a parentheses here. So if we can make either this side 0 or this side 0, that would give us a real nice solution. So let's start with the parentheses. What can we plug in for x here that would make this whole parentheses equal to 0, effectively making the whole equation 0? This is x plus 5. So what can we add 5 to get 0? Hopefully you guys are thinking negative 5 plus 5. Let's just check. If we did negative 5 plus 5, would that equal 0? It would, and 0 times anything is equal to 0. So one of our solutions here is negative 5. That's one of our zeros. What could we plug, this is kind of silly now, what could we plug in for x by itself to make it 0? Maybe seems like a trick question, but the number we could plug in here for x that makes that 0 is just 0. Right? 0 is 0. So our other solution here is 0. All right? So our two solutions here, if we were to graph this, our graph would look something like this, and we would have a 0 at negative 5 right there, and we'd have a 0 at 0 right here, and I can see this is a positive graph, so it looks something like this as well. And there you have it. That is the easiest way to find your zeros if your equations look super nice like this.